Guys, back to Unit 8, and this is the last indicator for Unit 8, and this would be indicator 30. And in the earlier one, we just talked about, in indicator 29, we talked about functions, function rules, and how to, we talked about ordered pair. I just want to show you what mapping diagram is also. Because I ran out of time on the earlier one, but it's just something I would like you to have a knowledge of. And in this indicator, learning target, I can create graphs, tables, and equations that represent the same relationship. Okay, so in indicator 29, you were seeing the relationship between the independent and the dependent variables. You were able to see the relationship and put them in table format, develop a function rule. So it was all a relationship between an independent and a dependent variable. Okay, so now we're going to take those ordered pairs that we get from our function tables, and we are going to graph them, and we're going to be able to analyze those graphs. Okay, so as you can see, vocabulary, graphing. Okay, graphing is a visual representation of the data that you have. It makes it very easy to read. Okay, and then we'll talk about a linear function in a little bit, but basically it is nothing but linear line. So the graph should be a straight line of that function rule and not curved. Okay, so linear means straight, but we'll talk about that in a minute. So let's go ahead and let's say I give you a function rule of y is equal to x plus 2. Please remember, the y is your dependent variable because it depends on what x is. So x is independent, y is dependent. X is the input, y is the output. So do not forget this from the previous lesson, okay? So I'm going to go ahead and I am first going to create a table, okay? And I am going to do input. I'm going to put the rule over here, and let me do another column so that you can see what I'm doing. Okay, and then, okay, so we have input, which I told you was always x. Remember, we also said that the x is always on the x-axis. The input is always graphed on the x-axis, okay? Then we have the rule over here. I'm going to put that so you can see the calculation where it's saying y is equal to x plus 2. Then we have output, which is always y. And then I'm going to put over here the ordered pair. And we've done coordinate graphing before. So the ordered pair comprises of x and y. Okay, so I am going to give some values. Please have at least 4 values in order to plot your graph. Okay, so if I give values, if I say 1, if x is 1, if x is 2, if x is 3, if x is 4. I'm choosing these values, okay, because I just have a rule right now. So if I follow the rule for y, x plus 2. So what is x over here? X is 1 over here. X is 2 over here. X is 3 over here. X is 4 over here. And then my rule is x plus 2. So plus 2, plus 2, plus 2, plus 2. That doesn't change, just the x changes based on what value I've given to x. All right, so I'm making a function table right now. So now, when I do 1 plus 2, I get y. So 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. Okay? If I was doing a relationship between the independent and the dependent variable, I could easily see as the independent variable increases by 1, the dependent variable variable also increases by 1. So if you were to write a relationship like we talked about, okay? Now, the ordered pair is your x and your y. So you get 1 and you get 3. For 2, you have 4. When x is 3, y is 5. When x is 4, y is 6. So this is how you make your ordered pairs, okay? Now, mapping diagram that we had talked about earlier, it is nothing, guys, but you basically have your input, and I'm just showing you what a mapping diagram looks like, okay? And this is just something so that you have a knowledge of this in case you see this. You have a mapping diagram of a function rule. You have input, you have output, okay? And so in the input is what? X, and output is Y. So you just make 2 ovals like this. All right, put your input from the smallest to the largest number if it is not organized. But over here you can see it's already organized. And so I'm just going to write 1, 2, 3, 4. These are my input values. Now what are my output values? I have 3, 4, 5, and 6. So basically just how you make the ordered pair. The only thing, please remember that I'm making an arrow which is one-sided. Don't make the arrow backwards, okay? From the input, from 1, I get 3 when I solve it. So look how my arrow is going towards 3. Do not put the arrow backwards. Input to output, okay? That's a function. So 2 and 4 in this case. 3 and 5 in this case, 4 and 6 in this case. So that is basically a mapping diagram. When I look at this, I can just see that my ordered pairs are 1, 3, 2, 4, 3, 5, 4, 6. So mapping diagram is just shown in that way. It just gives clarity for you to see the function connected to from the input to the output. And that's all that a mapping diagram is, okay? Now, let's go ahead, take my ordered pairs, and I am going to graph this. I am going to graph this, okay? So, I'm erasing this part. Just wanted to show you what a mapping diagram was. And remember what we've done in the past, okay? This is my x-axis. Since I can see only positives over here, I just need quadrant 1. I don't need to be doing quadrant 2, 3, 4, where you have negative, positive, negative, negative, or positive, negative combination, because I can see x and y are both positive. That means they are only going to fall on quadrant 1. So that's all I'm going to worry about right now. I'm just going to take it like this. This is, remember, x, this is y. All right, the independent variable x is always plotted on x, and that is the horizontal line. The dependent variable, which is the output, is always plotted on the vertical line, which is y. Okay, so here we have 0, and I am just going to do 1, 2, 3, 4, 5, 6, 7, and same thing here. Please write on the left and make these little lines in even distance. Please don't have numbers floating in space like this, because then I'm not going to take it off, since I don't know where in the world 2 is, where in the world 3 is. You have to show it by this little line which is going through like this. Okay? So 4, 5, 6, 7. Okay? Now, let's go ahead and graph. The first one is 1, 3. So I look at 1 over here on the x, and then I look at 3 over here on the y. So this is how you are graphing. And this is my 1, 3. Okay? So this is 1, 3. Then I look at 2 from here and 4 from here. So this is 2, 4, and then 3 from here and 5 from here where they intersect. That is my point. And then 4 from here and 6 from here, okay? And where they intersect, that is going to be my point 4, 6. And once you have done this, you need to connect these with a line, okay? So there is your line, okay? This is your function graph, all right? For the rule, y is equal to x plus 2. Now, let's quickly talk about, since I've just shown you how to graph it based on a rule that is provided to you, I also want to quickly talk to you about what is a linear function. So a linear function is a function or is a graph, in which you have a straight line. So function whose graph is a straight line is a linear function. So since this is a straight line, this is a linear function. Okay? And just think of it. Linear has line in it. So therefore, any graph that has a straight line is a linear function, okay? If I had a graph which came out, let's say this is my graph, and my graph came like this. Is that straight? No, that is a curved line. It is not a straight line, so it is not a linear function, okay? If I had a graph which was like this, if it went like this, and like this, and then I have this. Okay, now once again, it is not going in a straight line. It is coming down first, then it's going up. It could be going zigzag, we don't know. But it is not a straight line. So again, this is not linear. This is, let's say this is going like this. This is not linear, because it is not a straight line. Only when we have a straight line is it a linear function, okay? So this is the graph of a linear function. Now, let's quickly analyze graphs, and that means I am going to give you a function rule, and let's say, well, let's do it this way. Okay. All right. So your sister earns $10 per hour. Okay. $10 per hour. And your brother earns $7 per hour. Okay, whose graph will be steeper? Okay, so if you have like this, please immediately first write out what your function rule is. For your sister, you know that the earning, just say y, which is the output, that is the earning, is equal to 10 times per hour. That means 10x. Because this depends on this, how many hours you work. Okay, so this is your sister's. Your brother's, same thing. Y is equal to $7 per hour, so 7x. If you choose to write other alphabet letters in order to represent your graph, that is fine. Okay, like for example, if you just write y is equal to 7h, h is standing for hour. But please know that that is your x, that is your independent variable, and y depends on that x. Okay, how many hours you work. So in this case, we are going to make two graphs because you have to graph both of them on the same graph. So I'm just going to first make two tables. okay? And I'm just going to write input, output over here. This is y is equal to 10x, and here y is equal to 7x. So I'm just going to show the rule like this, and then I'm going to have my, let me do this. This is my x, this is my rule, which is y is equal to 10x, and then this is my y, which is my output, okay? And same thing here. I'm going to cut it into 3 parts. I have x, which is my input. I have my rule, which is y is equal to 7x, and then I have, this is going to give me y. Okay, so let's go ahead and do the 4. Like I told you, you've got to have 4 values at least in order to graph it out. Okay, so I'm just going to give values to x. I'm going to say 1, 2, 3, 4. Okay, so y is saying 10, and x means what? Times x. So I'm just going to write 10 times over here so you know what I'm talking about, because it is 10 times x. And over here you can see x is 1, x is 2, x is 3, x is 4. So I am just making this. It will help me graph. And so 10 times 1, y is 10, 20, 30, 40. So these are my values. And then if I look at my ordered pairs, it will be 1, 10, 2, 20, 3, 30, 4, 40. So those are going to be my ordered pairs. Okay? So let's do the same thing here. 1 hour, 2 hours, 3 hours, 4 hours. And my rule is 7 times x. So I'm just going to write 7 times because that x is changing. All right, so times 1, times 2, times 3, times 4, because that's what x is. And I have 7 times 1, 7 times 2, 14, times 3, 21, times 4, 28. So these are my measures, my coordinates, my ordered pairs for this function is 1, 7, 2, 14, 3, 21, 4, 28. Okay, now if I were to graph this and then analyze the graph, so let's go ahead and graph this. Remember, this is, well, here we go. So, well, I shouldn't have really changed this one, but oh well. Okay, 1, 2, 3, 4, 5, 6, 7. This is my number of hours worked. Okay, number of hours worked. And that is my independent variable. Please make sure that you label your graphs. Okay, if you are given something based on word problems, make sure you label your graph. And then over here, I am going to change it 5, 10, 15, 20, 25, 30, 35, and I will take it to up here. Okay, I am going to change the intervals on this side, which is the money earned. Okay, this is the money earned, and because this is dependent on how many hours you work. Okay, so I'm just going to make this 5, 10, 15. I'm making my intervals. Remember, the intervals have to be the same. 30, 35, and this is 40. Okay, remember, these intervals are the same, these intervals are the same. Now both sides intervals don't have to be identical, but whatever interval you're using, if I'm using 1, 2, 3, 4, it needs to be 1, 1, 1, 1. I cannot say from 1 I jump to 10. That will make the graph totally incorrect, very misleading. Okay, so let's do y is equal to 10x first. So my ordered pairs were 1, 10. Okay, so I am going to use the red color for y is equal to 10x. With 1, I have 10. Okay, with 2, I have 20. Okay, so this is 220. So this is 110, 220. With 3, I have 30. Okay, so this is 330. With 4, I have 40. So this is 440. And remember, ordered pairs are always written within parentheses. And then I am going to connect the dots. And this graph is y is equal to 10x. That is your sister's earning. Let's do your brother's earning now. And let me use a different color. And if it's saying 1 and 7, so at 1, this is at 7 will be somewhere because this is 5, 6, 7, 8, 9. So this is 6, 7, 8, 9, 10. So 7 will be somewhere here. Okay, so if I go like this, at 1 and 7 here, and then 2 and 14. So 2 and 14 will be here, and 3 and 21 will be here, and 4 and 28 will be here. So this is my brother's, not mine, your brother's line is going like this. Okay, so y is equal to 7x. Okay, now when you're comparing the lines in a graph, obviously the one, now these are both linear graphs because they are going in a straight line. Believe me, if I had a coordinate graph provided to me, it would look way more straighter than it is on the whiteboard. However, you just need to know the graph where y is equal to 10x. Obviously, the one which is on the left, which is going up much faster, is going to be the steeper graph, okay? Because it's saying which graph is steeper, explain. Obviously, because your sister is earning more per hour compared to your brother. So because the earning is more per hour, that graph is definitely going to be much steeper than another person, than your brother, for example, who is earning less. So the steepness of the graph depends on who is earning more. And in this case, it is your sister. So when you are comparing those graphs, you can easily see the one that's going straight up. Remember, steep means the incline of the graph, okay? So, and which is rising faster. So that would definitely be your sister's graph when you are looking at this graph. And then you know that that's because your sister is earning $10 an hour, which makes her income much higher compared to your brother, who is earning only $7 an hour. Okay, so this is how you analyze graphs, just by looking at how steep they are. Okay, and that's basically what this indicator is. But I'm just going to quickly throw a question at you where you see, I just want to show you whether it's a linear graph or not, so you can understand really quickly what that means. Okay, so if I give you a graph and I say that the input-output table already, the points are provided to you, okay? So you have this given to you, and you have your input, which is x, you have your output, which is y, okay? And then I have 0, 1, 4, 9, and then I have 0, 1, 2, 3. So these are my coordinates that are given to me for my input and my output. And it's saying, does the input-output table represent a linear function? Explain. Okay, so we are just going to go ahead and graph this. Okay, and this is 0. And then I have, wait, let me pull this down so you can see. All right, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I am going to go here 1, 2, 3, 4, 5, 6. So remember, this is X, this is Y. So let's graph this. If it's saying 0, 0, that's basically the origin. So this is 0 on the X, 0 on the Y. Okay, so this is my 0, 0. Well, let me use a different color actually. Here, this is my 0, 0 over here. The next ordered pair is 1, 1. So here's 1, here's 1. So this is your 1, 1. Next ordered pair is 4, 2. So this is 4, this is 2. Okay, so 4, 2. And then the last one is 9, 3. So here's 9, and here is 3. And when I plot it, this is my 9, 3. And then I connect the dots. Okay, so look at this graph. Okay, does this look like a linear function to you? No, this graph is definitely not a straight line. This is not a straight line. So this is not a linear function. Linear function means that the graph will have a straight line. Okay, so just wanted to show this also to you. Once again, please remember, you are going to be given a rule, and based on the rule, you are going to create a table. Please organize your work, otherwise guaranteed you will make a mistake. So create a table in order using the rule to make an input and an output. Input is X coordinate, output is the Y coordinate, and then you graph it. Okay, and for analyzing graphs, if it's asking which one is who's earning more or who's earning less, it depends on how steep that graph is. Okay, so or you might have to plot both of them on the same graph and then determine what the comparison is about. Okay, so anyway, that concludes our unit 8, and that was indicators 29 and 30. Have a great day, guys.